Okay, so today our lesson is going to be on finding the area of regular polygons. Okay, and just a reminder of what a regular polygon actually is. A regular polygon means that all the sides are the same length and all of the angles are the same measure as well. So, for instance, like a square is a regular polygon, but we don't have to think of just about squares. They could be pentagons, hexagons, heptagons, nonagons, all those good things. So that just means all the sides are the same length, all the angles are the same measure, okay? And then we have some vocabulary that goes along with these regular polygons. One of them is a radius, which you might be thinking we already talked about radius with circles, but you also can have a radius of a regular polygon. So I'm just going to put a dot there in the middle of my regular, in this case it's a hexagon. Remember, hexagon means it has 6 sides. Okay, and a radius is a segment from the center to the corner of a vertex. So here, if I go from here to here, and there are actually 6 radii that are in this hexagon, so this is going to be a radius right here. So we're going to write that in there so we kind of remember. Okay, a central angle is then if I drew another radius right next to it. Okay, if I drew another radius right here, the central angle is going to be the angle that it creates. So this angle right here is going to be my central angle. And in order to know what the measure of that central angle is, we are just going to take 360 and divide it by how many sides? Well, in this case, we have 6 sides because it's a hexagon. So we are going to take 360 and divide it by 6. And each of those central angles is going to be 60 degrees. I'm not going to put that in the central angle spot just yet because I'm going to put something else in there, because we also have what's called an apothem. This is a brand new vocabulary word for you guys, and it is the segment that goes from the center straight down perpendicular to the side. Okay, and that's going to be in blue here. That's going to be our apothem. Okay, and the apothem bisects the central angle. So that whole red, what I have labeled there in red, is 60 degrees. However, it bisects that angle, which would make, it's going to be kind of hard to read in here. I'm going to erase some of my arrows so that I can actually see this a little bit better. Okay, drawn in here. That means it bisects, which means this is going to be 30 degrees, and this one is also going to be 30 degrees. And it says it bisects the side of the polygon, which means this side here is 4, so that apothem drops down in there, and this half would be 2 inches, and this half would be 2 inches. And then what else we got? We got perimeter. Perimeter is just the distance around the outside of the polygon. So in this case, our perimeter, it has 6 sides. Each side is 4 inches, so we would have 6 times 4 would be 24. Okay? All right, let's do a quick example of that again with a pentagon this time. Okay, so we're going to make 2 radii to make a central angle. Okay, so here's my 2 radii going to the corners. And our central angle, what is the measure of the central angle that I just made in green there? Well, it's going to be 360 divided by 5 this time, because the pentagon has 5 sides, which means that the measure of each angle is going to be 72 degrees. Okay, so then when I drop this apothem in here, so now I'm going to drop the apothem in here so that it is perpendicular. Now, since the entire central angle we set up here was 72 degrees, 72 divided by 2 is going to be 36 degrees. So each of these angles in here is going to be 36 and 36. Okay. And then what else do we know? Label the angles and sides created by the apothem. Well, 36 degrees. And if this whole side is 14, that means this half over here is 7 centimeters, and this half is 7 centimeters. Okay? And then look at what it asks us to do. It says find the length of the apothem using trig. Remember trig from chapter 9? We all did pretty well with that. Trig, remember, was SOHCAHTOA. So sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, tangent was opposite over adjacent. And when we're doing these with the regular polygons, almost every time we are going to use tangent, okay? So we just need to remember that the tangent of the angle, remember we call the angle theta, is going to be the opposite side over the adjacent side. So let's go ahead and use that idea here. So let's look. My red here is my apothem. So I am really just looking at one of these little triangles, okay? So I'm looking at a right triangle. Okay, I have a 36-degree angle, and I also have across from it, or opposite of it, is going to be my 7 centimeters, and my adjacent to it is going to be my apothem. So to figure out the length of the apothem, remember the tangent, the angle is always attached to the trig function, is going to be opposite, which is 7, over adjacent, which is our apothem. Okay, and again, just remembering that when we have the missing variable is in the denominator, that means that we are going to take and we are going to divide side length divided by our trig function. And when we divide the tangent, 7 divided by the tangent of 36, we get 9.6 centimeters. Okay, and then the last thing we're going to want to be able to find is the perimeter. And again, this is a pentagon which has 5 sides. Each side is 14 centimeters. 14 times 5 is 70 centimeters. So we're going to have to use a little bit of trig. We're also going to use the Pythagorean theorem to find some side length and information as well, but we'll do an example of that later. Okay, we're going to do, how about pause the video, and I would like you to fill out this information just like we did for the hexagon and pentagon. Find the central angle, apothem, length of the apothem, and the perimeter for this octagon, remembering that an octagon has 8 sides. So just pause the video, take a minute to try to figure it out, and then turn the video back on. Okay, so if you went ahead and did that on your own, you should have realized we have a 22.5-degree angle in there because the central angle is 45. To find our apothem, we just use trig. Opposite is 6, adjacent is A, and we get that our apothem is 14.9, and the perimeter is, each side is, the whole side is 6. There are 8 sides, so, or excuse me, the whole side is 12, and there are 8 sides, so 12 times 8 is 96. Okay, so you might be wondering, why do we care about the length of the apothem and what the perimeter is if we are actually talking about area? That's because the formula for the area of a regular polygon is half the apothem times the perimeter. So our formula every time to find our area, and again, I like to use 0.5 for a half just because it's easier to put into the calculator. We are going to have to know what our apothem is, so we practice finding our apothem there a couple times, and we also are going to have to know what the perimeter is. And then we just multiply those three things together in order to find our area of a regular polygon. Okay, so let's start with a nice, easy, level 1 type of problem where all of the information, almost all of the information is given to us. So our formula is half the apothem times the perimeter. Well, the apothem goes from the center straight down. So we know our apothem is 12.4. Okay, so that's easy to find. We didn't have to do any trig. We can just look at the picture and it's there. We also can find our perimeter. Our perimeter, well, this side length over here is 18. Okay, and there are 5 sides, so 18 times 5 is 90. So the only 2 things we needed are practically given to us in this example. So our area is going to be half the apothem, which is 12.4, times the perimeter, which is 90. And when we multiply those 3 together, we get 558 its area, so we are going to be in feet squared. So that was a nice, easy one. They're not all so nice, though. Okay, now we've got a regular pentagon. Okay, what we do know right now, right, we know that the apothem, this guy right here, We know that the apothem is 6.5, but we still need to figure out what our perimeter is. And in order to figure out what our perimeter is, oops, Stacy, let me erase that. In order to figure out what our perimeter is, well, apparently it's not going to let me erase that. Here we go. Okay. In order to be able to figure out what our perimeter is, we need to figure out what this, oops, daisies, value right here is. Okay. Well, if you notice, we have, I'm going to make it a little bit bigger over here. We've got a right triangle. Okay. Right triangle. I'm just taking that and putting it out off to the side. Here is 6.5 and here is 8 and here is our x. Well, we have a right triangle with two sides that are known, which means we are going to use the Pythagorean theorem to figure out that missing part of the triangle. So we would have a squared plus b squared equals c squared. So we're going to have a squared plus b squared equals c squared. And if we do 8 squared minus 6.5 squared, we get 21.75. And when we take the square root of that, we get 4.7. So I know that this half of the side is 4.7, which means the entire side is going to be another 4.7 over here. So an entire side length, if we add those two together, is going to be 9.4, which is just 4.7 times 2. Okay, so now we can find our perimeter, right? We have 5 sides. Each side is 9.4. So when we multiply 5 times 9.4, we get 47. So now we have our perimeter, we have our apothem. So now we can go ahead and go to our formula. Half the apothem times the perimeter. Okay, and when we, those are all multiplied together, when we multiply those three together, we get 152.75. If we are rounding to the nearest tenth, that would be 152.8. And we don't have any units, so we're just going to call it units squared. Okay, so there's an example of where I had to use the Pythagorean theorem to help me find a side length. Over here, doesn't look like there's a whole lot of information given to us right now, but we've got a regular decagon. Decagon means 10. Right off the bat, I've got a side length that is 7, so I can very easily find my perimeter. My perimeter is going to be its 10 sides times 7 is going to be 70. So that's nice and easy. Now to find the apothem, okay, and I always like to use the triangle at the bottom, like it just makes more sense to me. So I draw these two in, okay, and this is a decagon, so that central angle that I just drew in is 360 divided by 10, which is 36 degrees. So that blue central angle is 36 degrees. But when I drop that apothem in there, which I'm going to have to know, like that, that breaks that in half. So now I'm going to divide that by 2, and those little angles are going to be 18 degrees. So I'm going to zoom in here. This is going to be 18, and this is going to be 18. So again, I'm going to take this triangle right here, this right triangle, and I'm going to just make it bigger right below it so it's easier, not so crowded. So I'm going to take that green, I'm going to make it bigger, I'm going to label it. I've got a right triangle. Here's 18 degrees. Here's my apothem. This was my apothem, okay? And I do know the length of that bottom side because the whole side length, each of these sides, is 7 units, which means that apothem is going to break this side into 3.5 and 3.5. So this is going to be 3.5. Whenever I'm finding my apothem, I am going to need to use trig. So I've got opposite and adjacent, which means I'm going to have the tangent of my angle is going to be opposite, which is 3.5, over my adjacent, which is my apothem. And again, variable on the bottom means we divide 3.5 divided by the tangent of 18. So we're going to get that our apothem, in this case, is 10.8. So now the two pieces of information we need, the perimeter we found out really easily up here, and then the apothem is 10.8. So now my area, capital A, is going to be 0.5 times my apothem of 10.8 times my perimeter of 70. And when I multiply those three together, we get 375, whatever it is, units squared. So these are not super simple, very quick questions. You're going to have to look at the information. Everyone is a little bit different in order to answer them. So just make sure you're looking very carefully. It's not going to be a mental math. It's not just putting things in a calculator. You need to make sure you're answering all parts of the question. We got one last problem here. We got a regular octagon. All right, again, we know a side length is 15. That's good because we can easily figure out that our perimeter is going to be 15 times 8 because there's 8 sides in an octagon. So I can easily figure out my perimeter is 120. Hey, there's part of my battle, right? And then I've got an octagon. So I'm going to draw my central angle. And when I drop this apothem in, right, so I'm going to have, it's an octagon. So each central angle is going to be 360 divided by 8 because there's 8 sides in an octagon. So that whole central angle is 45 degrees, but we want just the little guy, which is divided by 2, which is 22.5 degrees. So again, to avoid all of the, like so much information in that tiny little spot, I'm going to take that triangle that I have, I'm just going to make it a little bit bigger right below here so we can focus in on what we know. Okay, here's my right angle. Here's my 19.6. I know that my side length is 15, so I know that this little guy is 7.5 and this little guy is 7.5. Okay, and what I need is my apothem. Okay, I don't really even need to use trig. I do know that this is 22.5 degrees. I could use trig. I could say that we could do it both ways and show you that you get the same answer either way. So you could do that the tangent of 22.5 is 7.5 over your apothem, which again, 7.5 divided by tangent of 22.5 gives you an apothem of 18.1. Or if you wanted to do Pythagorean theorem, you could also do that a squared plus 7.5 squared equals 19.6 squared. And when you take 19.6 squared minus 7.5 squared, you get that a squared is 327.91. Take the square root, and lo and behold, you get 18.1. So in this case, looking at the information that was given, you could either find the apothem by using trig, or you could find the apothem with the Pythagorean theorem because you do know 2 side lengths. Either way, you get the same answer. But now we do know that we have an apothem and we have a perimeter, so we can go to our formula. Half the apothem, which we said was 18.1, times the perimeter of 120. We multiply those 3 guys together, and we get 1,086 inches squared. So there you go. There's lots of information to unpack in here. So when you have finished these notes, please make sure you submit your notes. Okay, and then start working on the regular polygons class kick. Okay, you will also have time to finish it in class tomorrow, the class kick, so that way you can ask questions as you're working through it if you need to.